thrilled to host today's panel on one of the fastest moving and most transformative areas of hardware innovation, drone design and manufacturing. We're joined by 4 leaders working at the forefront of FPV, defense, and advanced manufacturing. Today, we'll explore regulatory hurdles, supply chain challenges, the potential US ban on DJI equipment, and how FPV innovations are reshaping defense and commercial drone development. We'll also get into the details of how ORQA, Vector, and Strongpoint Labs leverage 3D printing to improve iterative speed and reduce costs. Before we start introductions, I'd like to just go over a couple housekeeping things. If you have any questions or comments, please put them in the live chat you see at the right. And if you'd like to request a free SLS or SLA 3D printed sample, you can click the link in the video description to choose one of our over 40 different materials. You can also contact our sales team to talk about getting a custom sample of your own part printed. Now, without further ado, let's jump into a quick introduction by our panelists. Kaleb, why don't you start us off?
Yeah, I'd love to. Appreciate the opportunity to be here with everyone and looking forward to the discussion. So I'm the director of product for Vector. This is a defense startup. It's been in business for about 18 months and really came out of seeing a lot of how modern warfare has changed, especially in the battlefield in Ukraine. So a lot of the company comes from former military, tier 1, tier 2 special operations, and are very familiar with how things are evolving quickly.
Great, thanks so much. Vlatko and Antonio, would you give us a quick introduction to ORQA?
Yeah, sure. So ORQA started, we're based in Croatia, and we started in 2018. At that time, we were only a very small team of only 3 of us founders. Right now, we are at close to 200 people, mostly engineering and technical personnel in the assembly lines. Yeah, I mean, we have started as a consumer brand. Our first product was FPV goggles for fun, for hobby market. And yeah, I mean, in the last couple of years, we have pivoted a bit towards the defense. Also, completely related to drones, everything drones. We have completely vertically integrated our company, so we are basically designing and manufacturing everything. Everything that we have, we design and manufacture ourselves here in-house. And I mean, we have. From our beginnings, we have used 3D printing for the prototyping, and without it, I don't know how we would be able to do anything. Yeah, we will touch some details more in depth later.
Great, excellent, thank you. And Henry, do you want to finish us off with Strongpoint Labs?
Yeah, so hi, so I'm the founder of Strongpoint Labs, and our goal is to go ahead and just be a tech agnostic training and consulting and integration company that works alongside the DoD to kind of solve their problems on the ground. We've been in and around groups for around about the past 10 years, integrating different systems, building unmanned, uncrewed systems from the ground up, targeting their needs. So whether or not that's using a Pixhawk controller to make a UAV to do a certain thing, or just to kind of teach those tools to show them that it is not as difficult as it may seem. It is a steep learning curve, but it is teachable. Yeah, and there are a lot of technical tools that can be used to go ahead and solve problems on the ground. So that's our goal as a tech agnostic knowledge transfer organization. Me specifically, have been around the DoD for about 10 years, and yeah, looking forward to dive into some of these topics.
Excellent, thank you all. Henry, I'll come right back to you with our first question. As a DoD partner and training resource, you've seen firsthand how fast things are changing for the UAV world. What are some of the latest developments in the US policy towards drones in terms of compliance, regulations on different types of drones, drones as a service? What's the sort of latest finger on the pulse take of the US drone policy?
I feel like all of these can be split into what's on the hobbyist side versus what's on the defense side. So I'd say on the hobbyist side, there is a fear of remote ID, or remote ID. Everybody needs to have the license plate on their drone moving forward. So that's probably the big regulatory hurdle that's coming up. On the defense side or the commercial side, NDAA versus blue list compliance. I think would be one of the biggest. It's not necessarily the newest, yeah, but it is kind of still ongoing. It's still affecting the market today, and in terms of what companies are used, what hardware is used, and how difficult that hardware is to be acquired by certain groups. So I think that is probably one of the biggest ongoing policies that is affecting.
Got it. And Kaleb, going to you next, as one of those companies from which the DoD is procuring, and an American unmanned aerial systems manufacturer, what are the primary regulatory and procurement hurdles from your side? How are you dealing with some of these communication issues and challenges that they pose?
Yeah, it's a great question. I think, probably at least 70 to 80% of my time is spent trying to navigate this landscape. And I think the biggest hurdle for us and obstacle is just general uncertainty. The regulations are written in somewhat ambiguous ways, and then it's unclear what to expect in the next round of regulation. And then additionally, just the demand is uncertain. We have some new developments, but is that sustained demand? And so scaling is based on, forecasting over a certain period of time, and that period of time is increasingly shorter as uncertainty increases.
Definitely. I think uncertainty is something our European contingent is probably pretty familiar with. Vlatko, with ORQA locations in both the US and EU, how do you find regulatories different, the same? Have there been similarities between them that you've been able to overcome faster because you've gone through them already? How do you view sourcing and regulatory policy in these two regions?
Well, yeah, I mean, it's pretty much what the other guys just said. I mean, being the NDAA compliant and being blue listed is basically the norm today. And for us, not being American company, while our US is our main market, it's extra difficult. So I mean, all of our products that we plan to sell, that we are selling, need to go through very, very rigorous analysis to be blue listed. And I mean, the NDAA stuff is really making, I guess, everybody's lives much more difficult, because sourcing the parts which are China free, that means in some cases that the part has never traveled through China during the manufacturing process. It makes the life of all of us much more difficult. I mean, at the same time, it is actually stimulating the I would say the Western world to step up and to catch up with China and to start making really good and affordable products.
Mm-hmm. Definitely. And I think we'll touch on some of the sourcing issues, especially with China soon. And back to Kaleb, are there certain component categories that you found really difficult to source domestically, or have there been any policies that have either helped or hurt or slowed down or accelerated the sourcing strategy for Vector?
Yeah, sourcing is an incredible challenge, and there's like so many aspects of it. Obviously, chips are probably the most difficult thing to source domestically, or even just not domestically, but not from China. That is Antonio mentioned as well. And then there's aspects of that. The same chip is manufactured in 4 different factories, and those factories could be placed in different places of the world. One of those factories is probably China, and so you may actually be able to use that chip, but you have to have all the documentation to support that it doesn't come from that Chinese factory. That's difficult to procure. And then you have wafer manufacturing, and then you have assembly that may be in China. There's some countries that do manufacture the wafers outside of China, then they ship it to China, I think, as Antonio was mentioning as well. And so that's just really difficult to navigate that process. It requires almost like a full forensics team to track the supply chain of each item, and it's very labor intensive. But what that means too is that you develop a part, you're very incentivized to vertically integrate, I think, as ORQA has found out. But once you have vertically integrated, then each of those components on there are critical, because then now you have to spend R&D time to redo software and firmware as a result of a new chip, because the old chip is no longer manufactured at the non-Chinese factory. And so that just creates a lot of issues for sustained manufacturing and dependable supply chains that, again, come back to trying to satisfy a demand that's somewhat unpredictable and ebbs and flows.
Yeah, absolutely. For Antonio specifically, talking about like in that vertically integrated supply chain from a mechanical design perspective, have there been any regulatory changes or incentive programs that have affected the supply chain at ORQA, or because you've vertically integrated, you're sort of insulated from those changes in policy?
I mean, we are not isolated from that. I mean, it catches us on every corner. Yeah, as Kaleb just said, like chips are really, some of the chips are really difficult to source, especially if you go up in quantities, because at some point, if the quantities are high enough, then what we experienced, we became too large for the sources like DigiKey or Mauser, but we are still not large enough to buy directly from the factories. So that's one really big step that I guess everybody will face at some point. And the other thing is the regulatory things, because the regulations are changing day to day. So what the product that would probably pass today, it doesn't mean that it will pass tomorrow, and that's a problem, because it's I guess the whole directive is basically being designed and written on the go. So every day there is something new. So yeah, I mean it's and for us, of course chips, electronic parts, that's a hurdle. But as we have started manufacturing motors this year, I can say magnets are by far the hardest thing to source today, because the fact is that China is the only source of the neodymium magnets, and we are really searching around the globe for some other manufacturers of the neodymium magnets, and so far we couldn't find any.
Magnets, chips, wafers, the tiniest things can cause the biggest headaches, it seems. Henry, talking a little bit about some bigger things in terms of funding packages. I know some of the US, like the recent US developments in policy, have expressly pointed funding packages or tried to allocate funding resources towards better sourcing, domestic sourcing, and even 3D printing for these types of either drones or other military equipment. How do you see the funding landscape changing and affecting the drone industry in the next 6 months to a year to 2 years?
I feel like to what Kaleb said, it's unpredictable. It ebbs and flows currently. There seems to be messages and news outlets and messages pushed out to them about the increase in US drone dominance, and there's a large kind of message from top to bottom around that. But does the need follow that message right now? I think maybe. Some groups are getting more funding than others. It's inconsistent. There's a couple companies out there that are currently receiving it, but then it still runs into the compliance issue of what they can buy and kind of the knowledge around it, of whether they can get the waiver to run just NDAA or to go ahead and go full blue list. So there may be funding kind of switches over to, and I think there is a boom in interest, but whether or not that means a continued boom in that interest in the next 5 years it's hard to predict. I think right now there's going to be a lot of increases in technology. There's going to be a bit of a cat and mouse game, especially around counter drone solutions as well. So maybe that market can probably boom, but it's still going to ebb and flow as need changes.
Mm-hmm. Got it. Switching a little bit more towards the supply chain and production methods, or continuing to follow up on that. Henry, I think like when you said, especially with the counter drones and even more like defense drones, target drones, how do those sort of lower cost options, how are those going to be affected by a potential DJI ban? If DJI leaves the US market, is there operational capability that will suffer the most? Is that going to affect even more so the sourcing chain for US drone manufacturers?
I think the DJI ban is going to rock the market in a couple ways, but I'm not sure that the defense market is going to suffer. I think that there's going to be yeah, probably room for other places to grow, but DJI hasn't been really used by the DoD in a while. And maybe some systems sitting on shelves, getting dust. I mean, we did our first training in 2017 in Kuwait, and that was, whilst we were out there, all DJI systems were grounded. And like since that day on until now, I think all to most DJI systems in the DoD have been kind of grounded and have been put on shelves and replaced with other systems. There's still a large community of first responders though, and other communities out in the US that do rely on DJI. So I think that there's going to be a couple of markets that are hit, and maybe it provides a space for other companies to kind of jump in and fill the void, or maybe there's a rebranding of DJI as another company that then makes its way into the US, which I think there have been maybe ideas of that happening. So I think that there will be a void in some of those markets. From a hobbyist side, as somebody who builds those systems, there's going to be a pain for a new digital VTX link that kind of matches that quality, that penetration, that those kind of qualities of the DJI link. It is the favorite amongst a lot of people, and I think once it becomes more and more difficult to get the air units, people are gonna want more and more for a system that kind of matches this performance.
Mm-hmm. ORQA team, I know ORQA has pushed hard to design and manufacture so many of those critical components in-house. Is this an advantage you guys see coming up? Is it something that will just increase demand and cause a lot of changes for you? Or are you guys pretty separated from DJI in general?
So I would say this is like the biggest opportunity for us, to learn something new, to learn new technologies, especially 3D printing, CNC machining, injection molding. We're trying to separate everything from outside of the Europe, trying to keep everything in the house, especially sourcing the material. I mean, for let's say the current war between Ukraine and Russia created a huge opportunity for carbon fiber makers in Europe to lower the prices, because it was basically impossible even to find a supplier for the carbon fiber. Here, everything was based in China, and yeah, that's one of the biggest issues which we had. So we're trying to move everything here. At one point, who knows, maybe we're going to try to produce our carbon fiber sheets. So yeah.
And Kaleb, following up on that, as a domestic manufacturer, but primarily working with the DoD, doesn't seem like the DJI ban will have a huge effect on you. Do you see any sort of downwave impacts on Vector if the ban goes through?
I think it's, we'll see over time. It's difficult to really forecast that out, but I agree with Henry. I don't think the DoD is going to be necessarily affected directly, but I do think second and third, fourth order effects will have a trickle down effect. I think the DJI ban is going to primarily affect the most price sensitive customers, which that means you start with, the hobbyist. He's going to be, the one that's most disrupted. And then maybe law enforcement immediately after, as Henry mentioned also. But what that does, I think, on the second and third order effects is it creates a market gap for new entrants. And those new entrants may come in with a solution very similar to DJI. And coming from the military, I would have loved to use DJI on every mission. It's an incredible product. Just wasn't allowed to. And so therefore, if a new entrant comes to serve the hobbyist market and they are able to improve or at least reach parity with DJI, then I think that the DoD would be disrupted by that new hobbyist entrant. And so I think that's what we have to look at. We still need to look at the lowest common denominator, because as we saw in Ukraine, it wasn't the expensive, exquisite systems that were the most effective. It was the asymmetric effect of those small, low-cost systems. And so I think it'll play out over the probably next 12 to 18 months. But I do think there will be an effect. And I think it just comes down to companies having the wisdom to not over-engineer, keep things simple, solve things with open source, and look for those low-cost options that would be great for a hobbyist, and they just happen to also be really good for the military.
Excellent. Got it. Thank you. Staying with sort of FPV and more hobbyist type technology, ORQA team, I know you guys started out as primarily FPV and a lot of racing hardware, and that segment of the drone industry evolves incredibly fast, although we're seeing the whole industry is evolving pretty much just as fast these days. Are there any design practices from designing for FPV and racing that have dramatically shortened or changed your hardware iteration cycles as you've moved into different other segments, maybe defense or larger systems of the drone industry?
Yeah, I mean, just to clarify, we're still doing FPV, but it is now FPV for the defense use.
Yeah.
I mean, the whole thing with banning DJI, I have my own opinion on this. I don't think this is the right way to help the Western industry. It surely does open a huge market gap for some new companies, but the problem is that all of the Western companies are far behind technologically behind DJI. And I think Henry mentioned the digital video transmission. As much as all of the Western companies are trying to catch up with the DJI, including us, the thing is that the Chinese semiconductor landscape is so diverse that DJI managed to find a semiconductor company which would produce a custom video processing and a radio chip that will enable them to have such a great digital video transmission, whereas all of the Western world relies on the off-the-shelf components which are never meant to be used in drones. And I mean, all of the stuff that all of us companies that are doing this are using, all of these chips are not made for drones. And I mean, we can see many companies using, like, for example, NVIDIA Jetsons. Those things are not meant to fly. And these are basically, you're flying a computer which was never built for that. And of course, it will always be a suboptimal product in the end. So until the Western semicon companies realize that they need to start making dedicated components for drones, it will be very, very difficult to catch up with China.
Mm-hmm. It sounds like obviously there's a gap in the materials, in the technology and sort of expertise and design expertise, but then also in terms of skilled labor. And Kaleb, I know Vector has a pretty unique combination of ex-military and people who have operational experience, but then also people coming from other maybe more FPV hobbyist drone companies. Have you seen the combination of those skill sets impact the way that Vector designs and manufactures for the better, or what are the kind of the benefits of having both of those viewpoints working together?
Yeah, I think that's the secret to Vector, and that's the strength that we're betting on. You know, I think being in the military, I was often frustrated with the solutions that were fielded to me, and it was just like, man, if I could have talked to these engineers 18 months ago, I would have had a much better solution. They were on the right path. They were very, very close. A couple nuances they just did not understand that led the engineering team astray, and therefore this product is just basically useless at this point. And so that's what we're tied into very, very closely. A lot of us in this company have a lot of operational experience in Ukraine and in areas around Ukraine and other modern battlefields. So we're seeing firsthand how warfare is fought. You know, we're trained on the old school tactics of, you know, Ranger School and special operations and all of those things. So we understand what the needs are, the tactical gaps are, and then we understand how technology can fill that. And so what we're seeing is that feedback loop is just the critical advantage for us. Is we have integrators. Our training team, we call them integrators because we like them to integrate with the unit. We like them to go onto the battlefield. We like them to advise firsthand, be there in the trenches with the soldiers. So they're integrating with military units. They're getting those lessons learned. They're bringing those lessons back. They're doing two things. They're taking those lessons learned to military units and red selling for them, replicating the enemy threat so that they can practice fighting against what the modern battlefield would present them with. And then that feedback is coming directly to me to direct the product and our engineering team to design against those current gaps and the current needs of that operator. And then, we're making long-term scalable product as a result of that. And so I think that's really, really effective. And I think there's other ways to achieve that, but having, literally my desk next to the guy that was in Ukraine last week, I think, that's a really good way to achieve it.
Definitely. And that integration of experience and technical expertise, I know, is something that Strongpoint is also trying to focus on, Henry, and you bringing your expertise to these sort of operational units or public groups. Have you seen any creative sourcing or creative problem solving in your time? You're smiling already, so I'm excited to hear. But any sort of creative case studies that you have seen at your time with different DoD groups?
Yeah, I think where there's a will, there is a way. There are a lot of when groups are highly motivated to learn the technology because of either what they've seen in modern conflicts, or they feel that they have a lack of training, or maybe just personal interest. Whenever there is that motivation and they are linked up with the right people, then they can go ahead and they can find a way to acquire the right equipment and the right training. But there is often, weird and wonderful ways in which contracting works. Trying to get on to, if you don't have one, trying to get any work, you have to go through somebody, and so on and so forth. So it's all about relationships. It's not about the community that is trying to better the warfighter. So I think if there is a shared goal of trying to better the people who are downrange, with the equipment that can be provided and the training and the knowledge that can be transferred, and we're all trying to achieve the same mission, then whenever a team acquires something uniquely, or whenever a team has funding and somebody can accept, and we can work to get together to kind of reach that goal, then let's take it. I think everybody can get access. There's a huge need right now, and there's a lot of people who need support. So hopefully there's a lot of motivated people who can reach out to groups, and get the things that they need.
Absolutely. Well, I think one of the most creative ways that at least we've seen, although maybe we're biased, at alleviating some sourcing issues or problem solving has been 3D printing. So switching a little bit into the 3D printing side of things, starting with ORQA, I know, Vlatko, drones pack more capability into smaller frames every day. Things are getting smaller and more agile. What are the biggest mechanical challenges, like thermal or vibration dampening, rigidity, EMI shielding? What's becoming most critical for you guys as you're working in a pretty compact envelope?
Yeah, that's a very, very good question. Basically, I would say vibrations. That's the most common source of problems for the drones, which rely on the precise IMU readouts, and if you have an airframe which vibrates, which is not stiff, it's very hard or even impossible to balance such an aircraft. But by combining different materials with their different physical properties, it's really very, very possible to make fantastic flying platforms. For example, like what we can see here, this is our 5-inch platform. It is a combination of carbon fiber frame with the 3D printed TPU parts, which we did on Fuse 1, which mostly we use these like motor guards, which have proven to be super effective. Then some of the mounts for the GPS, for the antenna, which we really want to have as flexible as possible, so it wouldn't break when the drone crashes and so on. So I believe by combining different building methods and materials, you can do almost anything.
Mm-hmm. And I think, Antonio, maybe for you specifically, Vlatko just kind of touched on it, but when you're thinking about the different iterative stages of a new drone design, which are the components that you immediately say, okay, we're 3D printing these, and which are the ones that are still more advantageous to do through traditional means like a carbon fiber, or an aluminum, or just sourced materials?
So basically, as Vlatko said, like the parts such as side panels on a drone, motor guards, antenna mounts, even like a battery holders, some kind of rails, maybe even iterations of one-axis gimbals. Maybe also on this drone, we had some iterations of 3D printed these kind of antenna holders. We knew like from the beginning we won't be ready like for full production until we confirm it with the 3D printing. After we confirm 3D printing, then we are moving to the basic injection molding or over molding some electronic components. Regarding to the aluminium, so basically we know from the start the heat sinks on some electronics which are very important, such as ESCs, VTX, which produce a lot of heats. How we are gonna design them, where we're gonna position them. So these are the parts mostly which we change through the all phases of prototyping.
So for the heat sinks, you would stay with 3D printing perhaps longer until you've really confirmed with all the other sourced components that heat sink design is correct?
So regarding to the heat sinks, we keep with the aluminium, but let's say in the iterations of prototyping phases, we even like 3D print the heat sinks just to prove everything fits in enclosures because of the tolerance. You never know. It's much cheaper to 3D print the heatsink and see does it fit than to mill. You need to prepare the cab, you need to prepare the cam, you need to last few hours on CNC machine. Then is it maybe going to go to be anodized? So it's much faster to go with 3D printing in the prototype phase.
Yeah, definitely. I feel like 3D printing is the new measure twice, cut once. It's like 3D print 20 times and then maybe machine, hopefully just once. Kaleb, moving over to you. How does Vector view 3D printing? I know you're using it at a bunch of different stages for a lot of different applications, but how much do you rely on it, and how does it help you either speed up the iterative process, get products to market sooner, or just arrive at the final iteration a bit quicker?
Yeah, I think it all comes back to my initial point. The largest obstacle we're encountering right now is just uncertainty. Injection molding and some of these more permanent manufacturing processes are based in certainty. You go injection mold when you're going to sell 1,000+ units, and we just don't know if we're going to sell 1,000 of this version or if it will be changed. And so, but what we do need to do is we need to be able to scale manufacturing now and satisfy the demand. And then the other thing is, like, when we're sourcing components, due to changing the regulatory environment and components and all those things, and just the scale at which technology itself is advancing and incorporating new features and components, we just don't know exactly what the enclosure needs to look like. So as a result of all that uncertainty, 3D printing is a critical function for us. It allows us to immediately start manufacturing and start producing product that is a saleable product that we can then ship out. It looks good, it feels good, it is durable, it's pretty mass manufacturable, not to the scale that injection molding is, but I can definitely satisfy the demand that we have by scaling up and scaling down 3D printers, or using your guys' great in-house printing service. And so that allows me to move from the prototyping and iterative process into manufacturing using the same manufacturing technique, and then actually start shipping units to customers using that same shipping technique without having to pause and wait for injection molding and saying my product is now locked, and not really feeling very confident with that and investing $100,000 into injection molds. I can just continue doing 3D printing until I know for sure I'm going to sell millions of these, and maybe at some point it makes sense to do injection molding. But one of the great features too is that we're looking at Formlabs as the ability to provide the ability of injection molding even in low rate as well. And then one other thing I would just add too is, like, I think you're dead on, Olivia, with this is the this is your measure twice, your print twice, cut once solution, and especially with ergonomic aspects of the drone. Anything that needs to feel good in your hand, or fit in a case the proper way, or interact with a person. You want those things to be thoroughly tested, and injection molding allows you to do that over and over again and iterate and make a product that's really good. So yeah, I think it satisfies a huge demand for us, and we've been really thrilled at the partnership with Formlabs as a result of what we're now able to produce from day one.
Yeah, absolutely.
Add something. So we have tried something really new for us just last month. So we used what's the material?
So we use the rigid 10K.
Rigid 10K material to produce the injection molding molds, toolings for example for these antennas. And we successfully used this on our small injection molding device. So this is basically for us the first thing that we successfully injection molded by using 3D printed tooling. And I was very skeptical about this, but it turned out it works great, not for huge quantities, because obviously the material is not as hard as steel, but I think we made
over like 300 pieces.
300 units, yeah,
with one mold.
Yeah, and another thing I just wanted to add on what Kaleb said. For he mentioned testing ergonomics. For example, with this controller, we obviously 3D printed hundreds of prototypes before we went for expensive tooling, and we were able to test how the thing fits in your hands. We could test how all the parts inside the electronics, how they fit inside. Does everything click? Does everything work as expected? And I mean, this was, as I said in the beginning, and at the beginning, I really don't know how would we do this without 3D printing. I have no clue.
Mm-hmm. Well, that's great to hear. Formlabs and specifically is very happy to hear that. And yeah, I think the possibility for sort of low or short run injection molding with 3D printed tooling is massive. The opportunity there is incredible. Even for a low run like 300, very rarely do you need more than 300 at a time. And then if that doesn't work out, you don't need to scrap a steel tool. You scrap maybe $20 of resin used for that tool. What material are you guys shooting in? Like, what is the end use material of the antenna?
It's TPU. No,
it's PVC.
PVC, sorry.
Yeah, PVC material. Yeah.
Yeah, it was TPU, but then it was too soft. No, then we switched to PVC. Yeah.
Okay, nice. And then are the molding conditions different than you'd expect from a steel mold? Do you have to lower the temperature, or can you set the molding conditions at the same?
So basically, at the start we tried to use the same settings, but we realized that the pressure of the mold is maybe too high. Then we need to lower that. And also, yeah, you're correct. We need to lower the temperature because in this case of rigid 10K, the transfer of temperature is really, really slow, and then the parts need to cool down much longer. So yeah.
Got it. So slight adjustments, but it's still a viable process.
Yeah, we are still experimenting to get to the best settings, but I mean, this thing works. It's awesome.
Yeah, basically in like hour and a half, you can get you have done mold, just for some kind of a batch.
Excellent. I think people will probably have a lot of questions about that, which we'll get to in a couple minutes, but I just wanted to check in with you, Henry, specifically about some of the policies. I know there's been a lot of talk recently about a loosening of regulatory restriction on 3D printed end use parts, specifically for the drone industry. And I was just wondering if you think those restrictions are going to open up the landscape for more 3D printed end use parts in drones, or if you think it'll still mostly be a prototyping or maybe repair and maintenance factor.
I think that there's always going to be a place for 3D printed parts on drones, even if it's not straight out of the gate for production. If it's the second you crash it and you have to make an adjustment or you wanted to add something to it, there's always going to be kind of a room for that, and there's always going to be a community for that. I think as more and more is learned about how useful 3D printing is, as another pillar of manufacturing to lean on. More and more parts, more kind of things that will be allowed will kind of come into play. For a lot of the one-way systems, for the DoD, why does it matter? Like it only needs to work once. If it's 3D printed and you got a maximum of 50 flights that it's going to be kind of greenlit for, it only needs to fly once. So that should be the answer. So I think there's always a place for 3D printing. I think one of the better accessories to kind of FPV and something that can enhance your kind of FPV or drone experience would be to have some CAD experience in a 3D printer, because you're immediately going to start wanting to do things. You're immediately going to want to start integrating things. We've left teams after a training and we've come back 3 weeks after pushing the right direction, and they've CAD'd up their own dropper mechanism. They're telling us how servos work and integrate onto beta flight, and wishing it to be more like iNav, and that's just a push in the right direction. Imagine a formalized training around UAS specific fabrication techniques, how to optimize 3D printing and things like that. Then that team can be way more dangerous, or maybe the output could be. But yeah, that's my take.
Excellent. Yeah. Well, the more 3D printed parts that we get in front of people, I think hopefully that'll continue to influence policy, and it'll just be, a self-fulfilling prophecy, hopefully. So moving away from sort of 3D printing as a philosophy and getting a little bit more into the specifics of SLS, which both ORQA and Vector have leveraged to enormous success. Could the ORQA team talk maybe to begin a little bit about the durability of SLS, why you guys have decided to scale up with so many SLS 3D printed parts? I know you just shared a TPU part, which on the left side of the screen is our probably about 6 ORQA TPU 90A parts printed on the Formlabs Fuse 1. So yeah, could you just talk a little bit about the decision process for getting into SLS 3D printing and why you've liked it so far?
So let's sketch with those parts as are shown on the screen. That's actually these parts on this drone. So basically, we had a requirement to make a drone which will be used for the training, which needs to survive like a crash in a steel wall, concrete wall, drop from a few 10 meters. So, and we, just decided, hey, just let's buy, few kilograms of TPU and test it. And basically, after just few 3D prints, we were sure that we were gonna use it on basically on the first few batches of I think 600 drones, which we shipped to our customers, and they're in still perfect condition. So yeah, I mean, basically after that we moved to the injection molded TPU parts because it requires much more quantities, basically a few thousand fully built drones. So so 3D printing isn't that fast in this case.
Mm-hmm. And then Kaleb, how does Vector leverage SLS? What are you using it for, and why did you decide to go with the Fuse 1 system, or the powder production in general? I know you guys are using both nylon 12 and TPU. When do you use each?
Yeah, I think it's a lot of the same applications as ORQA is using it for. We really like the SLS, especially the nylon 12. Again, it's just like a good finish. It looks, professional. Customer has never, they don't even necessarily first think, oh, this is a 3D printed part. This is the drone. The part looks great. One of the really cool things about 3D printing is it allows you to do things you could never do with injection molding. It allows you to do things you can never do with milling. And so, the creativity of our engineers is just kind of unlocked. And sometimes that creativity leads to very innovative solutions. And so that's really good. And like I said earlier, too, it allows us to scale manufacturing really, really quickly because I can just continue to print more units here and then offload some of that demand to the printing service at Formlabs. But we're primarily using SLS nylon 12 for fairings and for mounts. The structure is coming from carbon fiber and from other, metal hardware as well. And then we do use TPU as well. I think as the ORQA team mentioned, certain mounts and things, the TPU is just such a ruggedized material that, it takes a hit and it keeps going just fine. And so it's the answer to a lot of problems that we encounter.
Yeah.
I just want to add something. I mean, especially this TPU material, it looks so good when 3D printed that you basically, I mean, even it's not just the looks, it's also the material properties are fantastic. And the only reason why we actually then later shift to injection molding is just the quantities, that the volume of the part that we need to produce, because it's not even the printing time, it's just the labor of unpacking files and the post-production that is taking too much time for huge quantities. But material itself looks fantastic. I really like this color, this gray, and also the same color is for the PA. But I mean, the material is fantastic. Just the labor that is needed to post-process the parts. That's why we have to switch to injection molding for the higher quantities.
Yeah. While we're on the subject of TPU, I just want to give a quick bump for variable durometer settings, which is new for the Fuse and new for our TPU. So the parts that you see on the screen and that ORQA just showed are 90A durometer, and then we've also released settings for 50A, 60A, and 80A TPU. So I think a lot of people, the 50A and the 60As are probably a little bit too soft. This part right here is 50A, and it's almost too flexible, but nicer if you print like a nice big chunky part. And then the 80A actually performs really nicely for vibration dampening parts that we've printed in-house. But I think, well, I had a question for Henry, is that a lot of the sort of in-field repair, maintenance, sort of on-the-go parts, are a lot of printers that can be easily transported or moved around or sort of banged up, which is not necessarily, the Fuse that we see here. That's not gonna do too well in a Humvee. But do you see any value for SLS having backstock of parts, or is the infield stuff primarily going to stay FPV, do you think?
No, I think that there absolutely is. I think that there are companies out there who are putting fabrication kits that can be deployed the size of shipping containers, out to forward locations to support teams by manufacturing their own drones and spitting them out as needed, and kind of being a decentralized approach to drone manufacturing. Could be a really, really interesting solution, but it is also a lot of hardware downrange, which now becomes a target and could potentially limit that. But in terms of machines, I think FDM probably makes sense. It's pick upable, movable, very, very easy to transport when needed. But kind of building a decentralized approach to manufacturing, having an SLS kitted out somewhere that can support. There are metal printers on ships now in the Navy to kind of build parts and keep the fleet going for longer. So there's going to be a lot of ways, maybe not in forward deployed locations, where 3D printing can support kind of the DoD operations. I've been part of teams that set up 3D printing labs that have SLS, SLA, 3D scanning, FDM, and traditional reductive machining in Guam and Hawaii. Like teams are doing that, and they want a decentralized approach to fabrication. So 3D printing slots into that really, really nicely.
Definitely, and I think, as you said before, the growing interest in CAD skills and just like everyone having a little bit more expertise in the design portion will only increase the number of those kinds of mobile labs or sort of semi-on-site decentralized labs that can pop up.
Yeah, I don't think you can stop it. It may not be in the initial design of the container. There may be a preset file list that you can pull from, and you just want to grab the file, put it in the machine, press go, pull it out, and do all the post-processing step by step. No creation, but people are going to start building their own files. people are going to start, figuring out their own solutions to their problems that they're encountering, because the set file list may not answer it the exact way that they want it. I think that we should kind of like build in an available platform for that creativity, because there are a lot of really great solutions created by the people who are running into that problem every day. So that's a fantastic resource that other people can leverage. It may not work for all scenarios, so there may have to be some filtering, but yeah, I think people will do that regardless.
Excellent. Okay, well, we're going to talk about SLA next, but I think what most people might be most interested in this conversation for SLA is probably more of the injection molding conversation. So I'd actually like to just skip to the SLA injection mold. And Antonio, maybe you could just talk us quickly through what's happening in this video and how you guys are preparing the injection molds.
Yeah, so basically in this video you can see the whole process of designing the mold, like the preparing for preform slicer for SLA printer, preparing it for CNC machine also, like the processes from washing, curing, like the whole process.
Yeah, absolutely. So is this showing like how much touch-up work to the rigid 10K mold did you have to do before getting it ready for the shots?
We just needed to do like dimension checks of outer dimensions just to fit it in aluminum, parts which will fit in a injection mold machine, nothing else. The hole sizes, the thickness of material, everything was perfect, like to 0.01 millimeters.
Thank you so much to our panelists. I really appreciate your guys' time, and thank you to everyone who tuned in. If you have any further questions, you can follow up with our sales team, link in the description, or follow up with any of our wonderful panelists. We can get you the right contact information there. So just want to say thank you again, gentlemen, and we'll talk to you soon.
Thanks, Olivia. Thanks, everyone.